So, today we are going to present our group project. We are from section 2 and our topic is conservation of energy. I want to introduce all my members in this group. First, MING, ISKANDAR SHAH bin Muhammad Sharif is me, Jeffrey bin Muhammad Iqbal, FARID HILMI bin Ismail, and HASSAN HABIB QAZI. Next, I will like to pass this presentation to FARID HILMI bin Ismail.
Assalamualaikum warahmatullahi wabarakatuh. Today I would like to talk about our group introduction and objective for work done and energy. For introduction, the work done on a system by the positive force is the product of the component of the force in the direction of motion times the distance through which the force acts. For one way, motion in one dimension, this is expressed in equation form as W equal to F E cos theta, where W is work, F is force, the magnitude of the force on the system, D is the magnitude of the displacement of the system, and theta is the angle between the force vector F and the displacement vector D. Work is closely related to energy. The conservation of energy states that the change in total energy of system equals the added heat minus the work performed by the system. Okay, for the objective, the first thing is we need to know what got many meanings in physics. So we must know there are many words in physics. So we must identify the different of the word work. Okay, next, understanding the concept of energy. We know that energy can be transformed and cannot be destroyed. Lastly, understanding of the concept of work in terms of product of a force and displacement in the direction of the force.
Define energy as the capacity to do work. This implies that energy is a more abstract concept than work. Work is certain and important manifestation of energy. Indeed, the Industrial Revolution went into full swing in late 18th century when breakthroughs were achieved in converting other forms of energy into work. Furthermore, energy is a property of matter that can be converted into work, heat or radiation. Energy available in the universe is constant. It cannot be created or destroyed. It is only transformed from one form to another. In other words, it is conserved in all this transformation. For work, when we lift an object, for example, book, from one level to another, lay from the floor to a shelf on the wall, we expend our energy by doing work to increase the energy stored in the object. This energy can be converted back into work. For example, if we let the book fall back to the floor. In this transformation, the chemical energy stored in our muscle is converted to work, or more precisely, to mechanical energy. And work is converted into the potential energy stored in the object while it sits on the shelf. Though the full applicability of the work energy theorem cannot be seen until we study the conservation of energy. Next, we go to calculation.
I'm going to present about the calculation. First question we have chosen that is about the applied force versus the position graph. From there we are going to find out the kinetic energy of the heat by the object when it covers distance from 0 to 12 meter. Here we have a force versus position graph. On the y-axis we are having the force that is from -8 to 8 parameter, and for the distance it is from 0 to 0 to 12 meter. In this, by having this data from the given figure, by using work energy theorem, we see that area under the graph gives us work done by the force, that is kinetic change in kinetic energy, that is equal to work. Area under the graph we find it. After that we apply the we apply energy theorem, that is delta KE equals to work. So finally we got by the difference of 12.4 minus 8.4, we got the energy that is in joules, which is 16 joules. For the next one, we have calculation when box having a mass 3 kg thrown with an initial velocity 10 meter per second on an inclined plane. If the box passes from the point B with having the velocity that is 4 meter per second, find the work done by the friction force. Here we are using conservation of energy theorem, that is equals to energy EA equals to EB plus work friction. By solving the equation, finally we got work friction that is equal to EA minus EB. 1.2 meter multiplied by V2 minus mgh plus half mdl2. Then finally, by doing the mathematical calculation, we found out the work done by the friction, that is equals to 66 joule. Now I would like to ask for the next presenter to come and continue the presentation.
Okay, thank you, Hassan. Okay, so I will continue the next two questions. The third question is, a car has a mass of 500 kg, is initially traveling with a speed of 80 km per hour. It slowed down at a constant rate, coming to a stop in a distance of 50 meters. So there are four small questions. First is, what is the change in the car's kinetic energy for 50 meter distance it travels while coming to a stop? Second, what is the net force on the car while it's coming to a stop? And see where is the force applied. Jadi, if the car slows to a stop on level ground, is the work done is recoverable. So this is the solution, and I already state how to get the answers. So the first answer is, initially the car has a speed of 80 km per hour, so has a kinetic of 1/2 mv square. We need to be sure to convert the speed into SI unit. After 50 meters, the car is at rest, so the kinetic energy is 0. B, the total work done on the car equals the change in kinetic energy. Total work done on car equals to force net times distance, so force net times 50 meters. Total work done on car equals to change in kinetic energy. Therefore, force net is equals to -1.2 times 10⁵ joules divided by 50 meters equals to -2.4 times 10⁵. So the next answer is, the force on the car causing it to stop is applied at the only point of contact the car has, the ground. The ground push on the car opposite to the car's motion. That's the meaning of the minus sign above, causing it to stop. You can tell this because a car's tire get hot from the friction force between them and the road. And the final answer for this question is, the kinetic of the car motion is turned into heat energy. The car's tire, the brake and the road get hot, so the work done on the car is not recoverable. So the next question is, a 1 kilogram ball is dropped from the top of a cliff and falls with a constant acceleration due to gravity equals to 9.8 meter per second square. Assume that the effect of air resistance can be ignored. So there's five small question is, first, by how much has the ball's gravitational potential energy changed after it has fallen by 10 meters? How fast is the ball going after it has fallen by 10 meters? What is the force, if any, that does work on the ball? How much work has been done on the ball? Is the work done on the ball recoverable? So, solution is, the ball's potential energy gets smaller by an amount, mgh, where h is the height through which it falls 10 meters. This energy change results from the work done on the ball by gravity. Numerically, change in potential energy is equal to negative plus mgh equals to negative 1 kilogram times 9.8 meter per second square times 10 meter equals to 1998 joule. B, we can find the speed in one of two ways. The first way is to realize the ball has a constant acceleration at 9.8 meter per second square downwards, and we can then find the time it takes for the ball to fall. It is harder than the second way. Since the work done by gravity is uncountable, we can say that the potential energy loss equals to the kinetic energy gained by the ball. Initially, the ball's kinetic energy is 0. So it is
Betul. Sama.
so C, it's the force of gravity that does work on the ball. D, the work done on the ball equals the energy change from potential energy to kinetic energy, or 98 joule. Plus, technically no, the work done is not increasing the potential energy, it is increasing it. We haven't converted energy into a form that we can tap into again. That's all.
So for discussion, we will discuss about the 4 questions we done in the calculation. So for the first question, we are doing the question which is the relationship between the work done, force and displacement moving by the object. We are using the graph and we calculate the work done just only calculate the area under the graph. So for the question 2, it's about the conservation of the kinetic energy and potential energy. Since we know that the energy loss in the system is equal to 0, so we can say that when the height of the object is increased, the potential energy will increase. For the question 3, we are also for the conservation of energy. Since the question shows that the object is moving in a horizontally, so the potential energy is always equal to 0. So that we can say, in other words, we can say that the total work done is equal to the changing of the kinetic energy. So we only using the formula half mv squared. So for the last question, we are talking about the potential energy changing to kinetic energy, which is from mgh change to half mv squared. So we have the assuming the free fall acceleration of the object is equal to the gravitational acceleration of Earth, which is 9.81 meter per second squared. So for this question also is no energy loss in the system. So for our project, we also discuss about the benefit of the conservation of energy, which is the first, reduce the cost. Since we have done the calculation, so we can prevent the energy loss. Other than that, also reduce the pollution of our environment, which is by decrease the waste of energy, by reduce the greenhouse gas such as carbon dioxide, nitrogen, carbon monoxide. So the global warming will be avoided. Last but not least, we also can maximize the resources of our Earth. So since nowadays we know that the resources are limited in our Earth, so by increasing the efficiency of the energy use, we can reduce the quantity of the market requirement, and the production for limited source will decrease. So for conclusion, conservation of energy is talking about the energy is the relationship between the force, displacement, velocity, acceleration, and time. So for this topic, we know that the conservation is usually occur in our daily life, and also last, the conservation of energy bringing benefit to us. Thank you.